Hi guys, good evening everyone. Welcome to the session and welcome to the ESE 2024 previous year question sessions. Yes, so all of you preparing for ESE, but not only ESE, because today is a subject control system, okay, which is there, of course, very important for GATE as well, and other exams also like HPCL, HAL, ISRO, everywhere it's going to be helpful. Okay, so all those preparing, you can also join it up. We are going to discuss today the engineering services previous year questions for these particular 7 years, that is 2017 up to 2023, because 2017 is the year where the new pattern of ESE was introduced, okay, the pattern that is currently followed also. So let's discuss up the previous year questions of that. And today that I'm talking, the topic that we have taken is the time response analysis, although a very fundamental topic, but with respect to engineering services, be it GATE or be it your EE branch or EC branch, very frequently the questions are asked from it. So you should try to take benefits of such areas which are mostly easy and lots of questions are being asked. Definitely, you should try to take advantage of such topics without any doubt. Right. Okay, just a moment. Yes, very, very good evening everyone. Keep joining. Okay dear, chaliye. Good evening Ashok, Dreamer, Bhanu, Dreamer, good evening, and yeah, thank you so much guys, thank you, God bless you. Okay, so let's get moving ahead. Okay, this is a regular introduction and all. So guys, as you know, whatever we discuss, be it the questions and its complete solution, concepts, whatever we learn today, you will get the complete PDF in my Telegram group. Okay, I'll share you the link also in the chat box, after some time. Okay, and other than that, all important updates about coming examinations, about GATE 24 and any other important concepts, you can join also for discussing the doubts. Right, good evening Shubhankar, thank you. And yes guys, 2023 UPSC mains results have been declared, and not only the results have been declared, but the interview slots are also announced. Okay, very soon from 13th of September the interviews are also starting, and if you're one of them qualified the mains and definitely going for the next step, that is the interview, the personality test. Okay, so you must be definitely worried about interview. Guys, do you want to have a free mock interview with a panel which is very similar to like a UPSC panel, a real time, actual time of atmosphere? Okay, so yes, BYJU'S exam prep gives you the free mock interview with the expert panel. What you have to do is just share your result. To share the result, link is in the description. Okay, and yeah, here it is the first question for all of you. Right, thank you Ruby, good evening. Okay, the unity feedback system as shown in the figure is characterized by GS equal to 1 upon S plus 1 whole square. GS is equal to 1 upon S plus 1 whole square. The output time response will have a damping factor zeta and a natural frequency omega n respectively as how much? Respectively as how much? Tell me. The output time response will have a damping factor zeta and a natural frequency omega n as how much? The very first fundamental question. Acha, we all know that whenever we talk about second order system, okay, this is a prototype second order system. We describe the forward path gain. Consider under unity feedback, we describe the forward path gain as omega n square upon S plus 2 zeta omega n, and solving up, you know how to solve the block diagram. Okay, the final transfer function for this second order. Okay, let's have a quick 1-minute review. Wherever a review required, we'll review and then we'll keep solving the questions. Okay, so CS upon RS, and after solving, G upon 1 plus GH, we are going to get omega n square is divided by S square plus 2 zeta omega n S plus omega n square, right? Okay, now all the behavior of the system, especially the transient behavior of the system, the poles that is going to be concerned with stability, all that will be dependent on this quadratic polynomial. Okay, so we put it equal to 0, and what we get the characteristic equation. Okay, so let me write down the characteristic equation here separately. CE standing for characteristic equation, that is S square plus 2 zeta omega n S plus omega n square equal to 0. Most of the important concepts and questions will be related to the step response. Okay, so here are the results about the step response. What is this? This is the step response. So now what is the step response? We all know. Okay, step response is the output, that is CT. I've called the output as CT. This is in S domain. So in time domain, we call it as CT, and the input is RT. The step response, okay, is the response when the input considered, okay, is the unit step input. When the input considered is the unit step input. So if I apply the input RT equal to the unit step input, okay, the response obtained, the general expression for the response obtained is given by 1 minus e power minus alpha t upon root 1 minus zeta square into sine omega dt plus phi, right? Where the zeta, we all know that zeta is known as the damping ratio. Omega n is the natural undamped frequency of the system. Okay, we call alpha damping factor, which is zeta into omega n. Omega d, the damped frequency, is given by omega n root 1 minus zeta square. And also zeta is represented by cosine of phi, or represented by cosine of phi. Acha, when you solve this characteristic equation, okay, when you solve this characteristic equation, you get the roots of characteristic equation, which are also known as the poles of the system. So what will be the roots? It is going to be given by minus zeta omega n plus minus j omega n root over of 1 minus zeta square. Yeah, you can also call it as minus alpha, because zeta omega n is the alpha, that is a damping factor, plus n minus j omega d. Okay, where omega d is omega n root 1 minus zeta square. So you can call it as minus alpha plus minus j omega d. Okay, where alpha and omega d are mentioned in front of you. Okay, and what are these? These are known as what? Okay, these are the roots of the characteristic equation, or you can call it as the poles of the closed loop transfer function. Okay, the poles of the closed loop transfer function, CLTF. Okay, we call it as the closed loop transfer function. Okay, now if I come back to the question, okay, the question says there's a unity feedback system which is characterized by GS given to you. The output time response will have a damping factor and natural frequency. Very, very fundamental question in that case. Okay, because what you have to do directly, don't be concerned with the transfer function. You can directly work it on the characteristic equation. What is the characteristic equation here? Acha, in general, what is the characteristic equation? Okay, in general, what is the characteristic equation? In general, the characteristic equation is given by 1 plus GSHS equal to 0. 1 plus GSHS equal to 0. Okay, so I can directly take 1 plus GSHS, that is 1 upon 1 plus S plus 1 whole square. HS anyways 1 hai, unity feedback hai. Okay, so HS is 1 equal to 0. So when you solve it, let's open S plus 1 whole square. So S square plus 1 plus 2S, A square plus B square plus 2AB plus 1 equal to 0, right? Or I can say that it is S square plus 2S plus 1 plus 1, 2 likh dete hain, equal to 0, and I am in a position to answer it. This is omega n square. So what is omega n? Is root 2. Omega n square, because we have to compare it with this standard characteristic equation. Okay, and then what is the value of zeta? Okay, this is 2 zeta omega n. 2 zeta omega n, but already told omega n is root 2. So 2 zeta omega n is 2. Solving, you are getting, solving this, you get zeta as 1 by root 2. Okay, solving this, you get the zeta as 1 by root 2. Okay, so zeta 1 by root 2, that is 0.707, and omega n is root 2. That is the option number C is the very correct answer. Correct answer, Sai. Okay, so the very correct answer is the option number C. The very correct answer is the option number C. Right, dear? Okay, chalo. Moving ahead to the next question then. Okay, and then like this, okay, with some question, whatever review is required, we will keep revising the formula also, so that this session, of course, will be a ESE previous year question practice for you, but other than that, you revise up the important formulas also with respect to time response analysis. Okay, next question, the transient response of a second order underdamped system starting from rest is given by, okay, A e power minus 60 sine of 8t plus theta. Okay, and what is the natural frequency of the system? What is the natural frequency of the system? What is going to be the natural frequency? Now, what is this? In general, what is the expression that should turn up here with the amplitude is e power minus alpha t. Okay, the decay term. Okay, so alpha is 6 and sine of omega dt plus phi. Okay, sine of omega dt plus phi. So, omega d is z. Okay, so now this is also most of the questions ESE will be formula based. Some question will be taking your basic concepts, and I will show you that also factual based question. Okay, so alpha, which is zeta into omega n, will be equal to 6, and omega d, which is omega n root over of 1 minus zeta square, will be equal to 8. Okay, first of all, if I divide these two, okay, so omega n will cancel. I actually want omega n, but yeah, first let's start with zeta. So if I divide these two, alpha upon omega d, so omega n will get cancelled and you will have zeta divided by root 1 minus zeta square, that is 6 by 8 or 3 by 4. Now normally, okay, you can start making this as a quadratic equation and solve, but you know, you must know the quicker techniques also. What you can do, as I told you, zeta is given by cosine of phi. Okay, so zeta is cos phi. So under root 1 minus cos square theta, under root 1 minus cos square theta is sin theta. Okay, so this is equal to 3 by 4, or sin upon cos karenge, this is tan phi, and tan phi is 4 by 3. Tan phi is 4 by 3. So yahan se phi aa jayega. Okay, let me yeah, you can calculate this. Acha, but yeah, if we talk about ESE point of view, okay, if we talk about ESE point of view, you can manage without calculator also. Okay, because tan phi aa gaya to sec phi bhi aayega, or you can solve equation only, that is also okay. So if we strictly talk with respect to ESE point of view, so I can write this as square kar dete hain directly. Okay, so 16 zeta square is equal to 9 minus 9 zeta square. Okay, so I have 25 zeta square equal to 9. So what is zeta? Zeta 9 by 25 ka under root, that is the 3 by 5 and 0.6. Zeta would not be negative, so that is why I am avoiding the minus sign. So zeta is 0.6, and agar zeta 0.6 aa gaya hai, so what is going to be omega n? 6 upon 0.6. Yahan se nikal lenge na. Okay, 6 upon 0.6, and 6 upon 0.6 is going to be 10. So the correct answer is option number C, that is equal to 10. Yes, that's my correct answer. Okay, option number C, that is 10. Simple question again. Okay, so let's move on to the next question, guys. Let's move on to the next question here. If the characteristic equation of a closed loop system is given to you, then the system is what? Okay, now based on the value of zeta, okay, when is a system overdamped? The system is overdamped for zeta greater than 1. The system is critically damped for zeta equal to 1. Okay, the system is underdamped for zeta between 0 to 1, and the system is undamped, okay, oscillatory for zeta equal to 0. Okay, and if zeta is less than 0, then the system is negatively damped. Okay, then the system is negatively damped. Now what is the equation given to you here is, what is the equation? First of all, your characteristic equation normally should start with s square. So what you will do is divide by 2. Okay, so s square plus 3s plus 3 equal to 0. Meaning that omega n ka value root 3 hai, and then 2 zeta omega n, okay, is equal to 3. 2 zeta omega n is available here. So what is the value of zeta? 3 divided by 2 root 3. Acha, 3 by root 3 will become root 3. So it is root 3 by 2. And that is less than 1. Okay, that is less than 1. Root 3 is 1.7 approximately also if you take. So divide by 2 will be definitely less than 1. This is positive and less than 1, so the system response is underdamped. System response is underdamped. 2017 ECE question. Underdamped. Will come up to all odds 2017, 18 up to 2023 that mix kiya hua hai. Okay, it is to the underdamped. Very clear everybody? It is underdamped. Done hai ji. Chalo, cool. So the system response is underdamped. Acha, by chance one more thing, if zeta is, chalo yahan pe to sara range aa gaya. If zeta is negative, then we call the system as negatively damped. Negatively damped, and also in that case the system would be unstable. In that case the system would also be unstable. ठीक है जी. Next. Oh, sorry. What happened? My pointer range so fast. Just a second. I think just a moment. Yeah. A second order system with a 0 at -2 has its poles at -3 plus J4, -3 minus J4 in the S plane. The undamped natural frequency and the damping factor of the system respectively are how much? Okay, the undamped natural frequency. Now we can solve the question only by the knowledge of the poles, isn't it? We can solve it only by the knowledge of poles. Okay, what are the poles given to you here? Are -3 plus minus J4, and you can compare it with minus alpha plus minus J omega D. Okay, ठीक है, so alpha, which is zeta into omega n, is equal to 3, and omega d, which is given by the formula omega n under root of 1 minus zeta square, is equal to 4. Okay, now guys, if you focus on zeta into omega n, they are asking both omega n and zeta. 3 into 0.8 is not 3. Okay, 5 into 0.8 is 4. 3 into 0.6 is 1.8. 5 into 0.6 is 3. So sometimes, okay, you can take the benefit of the options. Save your time, guys. ESE mein especially, in exam like ESE, time is very, very crucial. Okay, so if I just multiply, okay, 5 and 0.6, then only 3 is coming. In none of the other option it is coming. Okay, the correct answer is D. The correct answer is D. ठीक है जी? Directly. Okay, so option elimination and option matching. Otherwise, okay, no problem. We have two equations we can solve. We have taken one such similar question today only. We can solve, but here I think not needed. ठीक है जी? So let's move ahead to the next. If not needed, इतना ही exam में करेंगे. Let's move ahead to the next. What is the error rate factor KE? What is the error rate factor KE to yield a damping factor? So you don't have to be concerned what other they are talking about. They are simply asking, आपको करना क्या है? You need a damping factor of 0.5 for the system shown in the block diagram. ठीक है? अच्छा guys, there is definitely a correction. I think sometimes they misuse this language. That this is not actually damping factor. Okay, they are looking for damping ratio. देखो, even if you solve it up completely. Okay, what is damping factor? See, what is damping factor? Damping factor is alpha, that is zeta omega n, and alpha to directly 3 hai, right? So omega n and damping factor, the second one is damping factor. None of the option has damping factor equal to 3. Okay, so hota hai, ESE may just be ready. Sometimes they don't put up the very proper language. Okay, they are asking zeta, but that is damping ratio. It is very clearly not damping factor, although it has a very clear relation with damping, but it is not properly known as a damping factor. It is damping ratio. Okay, जो सही है वो सही है. Although, but of course, in the exam time you can understand कि यार they might be asking about damping ratio only. Okay, so you can go ahead with that. But the actual language should be damping ratio. If they ask damping factor, that is directly equal to 3, but it is not in any of these 4 options. ठीक है जी? Next चलते. Similarly, next question also they are taking damping factor of 0.5. Okay, they are talking about damping factor. Okay, but please again take it as damping ratio. When you solve, you are going to match it with zeta only actually. Going to match it with zeta only. ठीक है? चलो check कर लेते हैं. Let us check it up. And once again, guys, characteristic equation. Once again, start with the characteristic equation. 1 plus GSHS equal to 0. So 1 plus SKE divided by S plus 2, right, into 10 by S into HS, which is 1, equal to 0. So if you solve it up, S square, then you have plus 2S plus 10 plus 10 SKE equal to 0. So I have S square plus S, okay, 2 plus 10 KE plus of 10 equal to 0. Plus of 10 equal to 0. Okay. 0.5 divided by 2.25. Correct. ठीक है जी. चलो. Now, once again, what is this? Okay, omega n square. So omega n is root 10. ठीक है. And then 2 zeta omega n. 2 zeta omega n is this term. Okay, that is 2 plus 10 KE. Okay, omega n is in front of you. What is zeta? Zeta is 0.5 required. Okay. We need the zeta of 0.5. So 2 into 0.5 into omega n, which is root 10, is 2 plus 10 KE. Okay, so 2 into 0.5 is 1. Now root 10 is a very commonly known value, although you will not use calculator, but we know root 10 is 3.16. Yeah, approximately pi. 3.1 for any one of them you can take. So root 10, 3.16 is equal to 2 plus 10 KE. So clearly you have got the answer. What should be KE? Minus here 2, 1.16 divided by 10, 0.116. 0.116. That is option number A. And I told you again that the option will match only by zeta, not by alpha. So it is damping ratio only. Okay, they are not writing it correctly, but okay, you can understand and go ahead with that. Okay, you can understand and go ahead with that. Moving ahead to the next question. Yeah, the output of a standard second order system for unit step input is given to you. What is the transfer function? See, it is a 2023 EC question. Engineering Services Prelims 2023 current year question. And let me also tell you that this particular question is also a gate PYQ. This question is also a gate PYQ, word to word. Word to word. ठीक है जी? It is also a gate PYQ, word to word. ठीक है, चलते हैं. So what is the transfer function of the system? Let's do it up quickly. Now how to do it up? Okay, so I've copied the transfer function here again. We know that e power minus alpha t. So what I'm able to obtain, alpha is 1. Okay, अच्छा. Then what is this? अच्छा, यहाँ से आ जाएगा simple. What is this? This is omega dt plus phi. Okay, अच्छा, ये actually cos के form में given है. What I can do is, okay, if I convert it to sine, then the answer is most likely coming to be very simple. So we can also write this as 1 minus 2 by root 3. 2 by root 3 की जगह लिख देंगे 1 by root 3 by 2. Let me write it as 1 by root 3 by 2. Okay, then I have e raised to the power minus t, and then I'm going to write sine 90 plus theta as cos theta. So cos theta है, okay, cos theta है, I'm going to write it as sine 90 plus theta. Perfect है, sine 90 plus theta is the cos theta. Okay, so if this is theta, add 90 to it. So you are going to get it as sine of root 3t, sine of the root 3t, okay, plus 90, that is plus pi by 2 minus pi by 6, so overall pi by 3 will come. Okay, 90 minus 30, that will be 60 degree, that is pi by 3 I can say. Okay, ठीक है जी. In the ISC series, Bhanu, you are telling? Okay, sine root 3 plus pi by 3. ठीक है, चलो. So now it is clear. This is alpha, and what is this? This is phi. So you are directly in a position to say zeta. As I have told you, zeta is cosine of phi. So cos of pi by 3, cos 60 degree is half. Cos 60 degree is half, that is 0.5. ठीक है. Now alpha, which is 1, is zeta into omega n. So what is omega n? 1 by zeta, and 1 by 0.5, that is 2. So what is my transfer function then? What is my standard transfer function then? My standard transfer function is omega n square, that is 2 square. Okay, this part is 2. Okay, it is 2 square divided by s square plus 2 zeta omega n s. Okay, so zeta is 0.5, omega n is 2, 2 zeta omega n s plus omega n square. So this is 4 upon s square plus 2s plus 4. Correct? 4 upon s square plus 2s plus 4. Yeah, here we have option number D perfectly matching up. Option number D perfectly matching up. Thank you, Tech. Thank you so much. God bless you. Yes, Bhanu, we'll have it someday in the morning. Yesterday it was planned ISC EMFT remaining part, but somehow yesterday I was not well, so at the end moment I could not take it up. Okay, but we'll take it very soon in next 2-3 days, but maybe in the morning slot, because night we are having this ESE PYQs question 9 PM, but we'll take it up. Hai? So I'll update you in Telegram. Right. Thank you, Venkatesh Rao. Thank you so much. अच्छा, ठीक है. Next question, guys. Next question. ESE 2022. The open loop transfer function of a unity feedback system is given to you. GS equal to K upon S tau S plus 1. Okay. By what factor should the amplifier gain be multiplied so that the damping ratio is increased from 0.25 to 0.75? Okay. What is the characteristic equation once again? So if I frame the characteristic equation once again, I am going to get it as 1 plus K upon S tau plus 1 equal to 0, right? So when you simplify this, okay, when you simplify this, you get S square tau plus S plus K equal to 0. Or you can also divide by divide by tau. So you can write it as S square plus, dividing by tau, I get 1 by tau S plus the K by tau equal to what? Equal to 0. Okay, and only the variable is amplifier gain K. ठीक है. अब देखो, again this is known as omega n square. So what is omega n? Root over K by tau. So what is going to be zeta? So I have 2 zeta omega n, that is 2 zeta root over K by tau is equal to 1 by tau. This is the term 2 zeta omega n. Okay, so what is the zeta? What is the zeta? So root k, tau and root tau will also cancel. 2 भी नीचे आ जाएगा. 1/2 root over of k tau. I think right? Yes. But very important is they are not changing tau. They want to check with respect to gain k. So what I can say is zeta is proportional to 1 upon root k. Zeta is proportional to 1 upon root k. It is inversely proportional to the square root of the k. Okay, by what factor should the amplifier gain k be multiplied so that the damping ratio is increased? Okay, is increased from 0.25 say 0.75. That means I can write down zeta 1 upon zeta 2 because it is inversely related. Okay, it should be root over k2 by k1. Okay, when you divide zeta 1 by zeta 2, तो zeta 1 का k1 नीचे आएगा, zeta 2 का k2 ऊपर आएगा. Okay, because they are inversely related. So what is the damping ratio? 0.25 से 0.75 I want. 0.25 up to 0.75. This should be equal to root over of k2 by k1. So I can say that what is k2 by k1? देखो, this is cancelled as 1/3. Okay, and then you square, it becomes 1/9. So what is k2? It is 1/9 k1. So with respect to the earlier value k1, it should be multiplied by 1/9, and 1/9 is 0.11. 1/9 is 0.11. That is the correct answer is option number A. The very correct answer is simply option number A. It is the option number A which is the very correct answer. ठीक है. अच्छा dear, one more thing I just want to update you. Just be updated. Just be updated about this. Okay, ये आंसर तो complete हो गया. But one thing I would like to update you is that tomorrow, okay, at the same time 9 p.m. please be noted about this. Tomorrow same time 9 p.m. Okay, once again I have the session that is in the IISc Bangalore PYQ series. IISc Bangalore PYQ series, that is the questions of 2016, 2008, 2002. Okay, the subject that I am taking is digital logic. Okay, now you might be thinking, sir, digital logic to already you have covered. Yes, I have covered the digital electronics question of IISc for ECEE. Okay, but tomorrow I am covering up the question under the computer science. But digital logic being a common subject, okay, all ECEE students can take the benefit of this for practice. Okay, so for practice, ECEE students can definitely attempt this. In fact, you will find some questions which are good in CSE, some better questions than ECEE also. Okay, so tomorrow digital logic, computer science and engineering ka hoga. Okay, for these 3 years. Okay, but ECEE definitely can watch it because it is a common subject, so you get the extra benefit. Okay, you get the extra benefit. Okay, also guys, now Thursday I will come back to the ESE PYQ. Thursday 9 p.m. Again the ESE PYQ like today, and Thursday we will cover up, like today we are covering up time response analysis. Thursday we will cover up the Routh-Hurwitz criteria. ठीक है जी? Thursday we will cover up the Routh-Hurwitz criteria. Thursday we are going to cover up the Routh-Hurwitz criteria. Next question, 2023, again a factual question. Okay, again a factual question more or less. Consider the following conditions for a second order system when subjected to a unit step input. Okay, with critical damping, okay, there are no oscillations. Okay, अच्छा, which of the above is or are not correct? हमें not correct वाला बताना है. हमें not correct वाला बताना है. With critical damping, there are no oscillations. This is 2. Okay, critical damping or over damping, there are no oscillations. Critical damping is that minimum level of damping at which oscillations are totally cut off. With no damping, the system oscillates, okay, with constant frequency and variable amplitude. No, if the amplitude is variable, that means there is some sort of damping. Okay, so this is definitely false. With no damping, actually, how is the waveform? For undamped waveform, आपको कैसा दिखता है? Undamped waveform is something of this kind. For a standard second order system, it oscillates between 0 to 2. Okay, this is undamped case. Considering zeta equal to 0, it oscillates with constant frequency and also constant amplitude. Okay, so ये false हो गया. With over damping, that is zeta greater than 1, the output takes longer time to reach the steady state value. The output takes a longer time to reach the steady state value. Correct? Yes. Over damped, slower. Okay. You are increasing the level of damping. Critical damping is already the damping where the oscillations are prevented. The damping goes away. Okay. But then you are introducing so high damping. Okay. That will make the system slower. Okay. So the output takes longer time. Yeah, that is correct. So which of the statement is false? Not correct. So it is option number C to be selected. It is the option number C to be selected. That is only 2. Okay. Thank you, Bhanu. Thank you. Right. Chalo. So this is it. A very simple factual question, you can say. Okay. And ESE will test sometimes your basic knowledge only rather than numerics. Next question. The largest error between reference input and output during the transient period. Now, many of the questions will be based on transient parameter. Very, very important transient parameter. So 2 minutes, let's have a quick revision and then let's come back to all such questions. Okay, so this is what is an underdamped waveform. Okay, this is what is a underdamped waveform. Okay, what condition is underdamped we know. Okay, this is the waveform of the system for the damping ratio bit less than 1. Okay, it is an underdamped waveform. And yeah guys, question में क्या बोला है? Difference between the reference input and the output during transient period, and the largest error, what it is known as, you should know it, what this is known as. Okay, this is the reference input. Okay, this is your reference input. This is with respect to step input. This is with respect to step input, and this is the maximum value of the output. Okay, so the largest error between the input and the output is this particular. This is the largest error. Okay, and what we call it as? It is known as the peak overshoot. I hope you are all aware about this. Very fundamental, and lots of numerical questions are expected on peak overshoot, not only ESE but even in the gate examination. Okay, so this is known as the peak overshoot. This is known as the peak overshoot, right? Okay, the first, or we can call it as the first, is always the peak only. The first or the peak or the maximum overshoot. First बोल लीजिए या peak बोल लीजिए, or you can call it as maximum overshoot. The first or the peak or the maximum overshoot. Then what is this known as? Okay, similarly this will be known as the first undershoot. Okay, so overshoot, shooting above the reference value. Undershoot, shooting below the reference value. This is first undershoot. Okay, so similarly this is second overshoot, second undershoot. Third overshoot, third undershoot. So overshoot and undershoot will alternate. Okay, the time at which the system achieves the maximum overshoot is known as what? Is known as the peak time. Okay, is known as what? Is known as the peak time. The time at which the system achieves the maximum overshoot. Okay, okay. Rise time, TR. TR is known as rise time, and rise time has different definition for underdamped and different definition for overdamped. You can have a look into it. Rise time is the time required. For your reference, for your revision, I have written the definition also, because I will share you the PDF anyway, so you will get all these notes as well. Okay, so it is the time required by the step response to reach the desired value for the very first time. Okay, so to reach the desired value. What is the desired value? That reference value is 1. Okay, what is the time taken to reach the desired value for the first time? This much. Okay, so the time up to this is known as the rise time. Clear? The time up to this is the rise time. But if it is a overdamped by chance, for overdamped it is defined as the time taken by the step response to change from 10% to 90%. Okay, for overdamped it is. Delay time, the time taken by step response to reach 50% of the desired value. Okay, desired value is 1, 50% 0.5. The time taken to reach up to this is known as TD. This is known as TD. That is known as nothing but the delay time. Okay, and then finally the settling time. Okay, up to the settling time we call the system in the transient state. This is the transient period, and beyond the settling time we call the steady state part of the system. Okay, right? Settling time, the time taken by the step response to reach 98%. 98% means assuming 2% tolerance. Okay, assuming 2% tolerance. That means my actual desired value is 1. Okay, we all know that to reach the actual value of 1, the system needs infinite amount of time at t tending to infinity, because मैंने आपको expression बताया था ना, What is the general expression for underdamped? 1 minus e power minus alpha t root over of 1 minus zeta square into the sine of omega dt plus phi and if t tends to infinity, then only the ct will be tending to 1. Okay, this part will become 0 and 1 minus 0 will become 1. Okay, ct will be tending to 1. The ct will be tending to 1 when t tends to infinity. Okay, for t tending to infinity. So the actual time taken to reach the steady state value, the final value 1 is infinity. Okay, so we take a tolerance, we accept an error. Okay, ki suppose whenever the output reaches 0.9. Okay, at this point the output value is 0.98. Okay, that is 2% error from the actual desired value. Okay, but again I'm telling, to reach the actual desired value, infinite time is required and we can't define what is the value of infinity. So we take an error ki, okay, let's say whenever the output reaches 98% value only, okay, we call that time as the settling time. We will assume that the system has settled and we define it as the settling time. Okay, now commonly we take it as 2% tolerance, but it depends on various situations. It can be 1% tolerance, it can be 3% tolerance, it can be 5% tolerance, any tolerance can be specified. Now maximum overshoot and peak time already I defined, the definition is in front of you, you can go ahead with this. Okay, acha, their important formulas then. What are their important formulas? Okay, rise time, okay, pi minus phi by omega d. Okay, the delay time approximately given by 1 plus 0.7 zeta divided by omega n. Next is what? Next is the peak time. Peak time is given by the formula pi divided by omega d. Next has settling time. Okay, settling time as per 2% criteria, right, is given by 4 by alpha, yeah, 4 by zeta omega n. This is as per the 2% criteria. Okay, this is for underdamped. Dhyan rakhna, this discussion is for underdamped. This is the settling time, 4 by zeta omega n. Okay, the 4 by zeta omega n. Okay. Now all these timing values one by one I have written, TR, TD, TR, TP and the TS. Also, what about the peak overshoot? Okay, the peak overshoot, as I told you, maximum overshoot, we normally call it as MP. Okay, yeah, let me give you the generic formula. Okay, let me give you the generic formula. Okay, overshoots ki agar baat kare. Okay, overshoots, the time to reach any overshoot. Okay, the time to reach any overshoot is given by n pi by omega d, where n is odd. The time to reach undershoots, ये सारा कुछ पूछा जाता है guys ESE में. The time to reach undershoots is also given by the formula n pi by omega d. Okay, but for even values of n. So for even values of n you get undershoot, for odd values you get overshoot. They keep on alternating. ठीक है. The first overshoot, okay, first odd value 1. First odd value 1, you get pi by omega d. That is the peak time. Okay, now the maximum overshoot. Okay, the maximum overshoot, it is given by the formula e power minus pi cot phi. Yeah, you can all, अच्छा, into 100 अगर percentage overshoot की बात करें, right? ठीक है, into 100. Or you can also write it as e power minus pi. Okay, e power minus pi zeta divided by root 1 minus zeta square into 100. Normally you find this formula in the books. Okay, but to make it easy for you to remember, I always put it as e power minus pi cot phi. We know cot phi is cos upon psi. Okay, cos phi is zeta, sin phi is root 1 minus zeta square. Okay, so you can remember any of the formula. Now this is percentage maximum overshoot. Maximum means first overshoot. Okay. If I want to ask about any other overshoot, suppose if I want to ask what is the second overshoot, then it will be given by the formula e power minus 3 pi cot phi whole multiplied by 100. Okay, right. In general, for any overshoot, you can use it as e power minus n pi cot phi into 100. In general, for undershoot, if they ask you what is the second undershoot value, not the time, but the second undershoot value, again use the formula e power minus n pi cot phi into 100. Difference कैसे create करना है? n will be odd for the overshoot case, n will be even for the undershoot case. For the undershoot case, clear? For the undershoot case. Okay. Hi, good evening Akish, thank you so much, God bless you. Okay, this is what it is. Okay, so now anything can be discussed here. See, like this was one direct information or definition based question. There can be many others. So like if I move forward, have a look into this. Directly they are asking some values. The settling time is the time required for the system response to settle within a certain percentage of what? To settle within a certain percentage of the final value. As I told you, that certain percentage, okay, that certain percentage may be 98%, right, or 95%, right, or any specified percentage, okay. The time taken to reach within a specific percentage of the final value is known as the settling time. So it is the option number B. Okay, next. See again, very formula based question. In an underdamped second order system, the time required for the waveform to go from 0.1 to 0.9. Now dekho, again, this is not the very correct way. Actual answer to rise time hi hoga, but 0.1 to 0.9 is the definition for. 0.1 to 0.9 is the definition for the overdamped. Okay, this should be, now in the question they have given underdamped, it should be actually overdamped. It should be overdamped. Definitely it is not peak time, settling time, final time. Okay, it is the rise time only, the time taken to go from 0.1 to 0.9, 10% to 90%, but this is the definition for overdamped. For underdamped, this is time taken to reach 0 to 100%. Okay. But okay, yeah, you know, in what happens, exam mein aaya, okay, so you are able to reach at least 10% to 90% definition comes in rise time. So you should mark rise time. Although the question is not 100% correct, but you can mark the rise time. Next, okay, again, a statement based question, 2022 ESE. Consider the following statements regarding the time response specification. Delay time is the time required for the response to reach 10% to 90% or 5% to 95% or 0 to 100. Okay, हमें क्या करना है? Which of the above statements are not correct? Okay, तो ये तो not correct है, false. Okay, delay time is the time required to reach 50%, ना 50% of the desired value. तो ये wrong है. Peak time is the time required for the response to reach the first peak overshoot. Yeah, for the first peak overshoot we call it as the peak time. This is true. Agreed. ठीक है. Next, settling time is the time required for the response to reach and maintain beyond a specified tolerance band, that is either 3% or 5%. As I told you, 95% if you take 5% tolerance, 97% if you take 3% tolerance. But this is not a 100% correct statement. The settling time is the time required for the response to reach and maintain. Okay, suppose it reaches 0.9. Okay, see, look into that waveform. It reaches 0.998, still it will be, you know, small fluctuations will be there, small oscillations will still be there, and after a large amount of time it will settle to 1. It doesn't maintain that 0.98 value. It doesn't stop at the 0.98 value. Okay, so that is why this statement is not fully correct. Okay, kahan chala gaya? The time required for the step response to reach and maintain beyond a specific type. Okay, no, maintain wala sahi nahi hoga. Okay, so the correct answer is, इसको भी हम false बोलेंगे. So which of the options are false? Yeah, not correct only. So it is 1 and 3. Option number B. Okay, maintain नहीं होगा. Okay, this maintain, this is not correct. ठीक है जी, this maintain, this is not correct. Alright guys, before I go to next question, just a quick reminder that like if you are enjoying these sessions, like this is also a practice session for ESE. Okay, so many other practice sessions are also available on the BYJU'S exam prep app. Okay, other than that, concept videos are available, guidance videos are available, and very important, daily quizzes are available. Okay, every morning you can just wake up and attempt a quiz of the subject of your favorite choice and keep your same, okay, you know, just put a regular habit ki daily koi na koi quiz aap de sakte ho to choose your favorite topic and favorite subject, and keep checking your competition with your fellow aspirants. Okay, every day you can check your leaderboard. So all these activities, whether quiz or concept classes, practice classes, many things happening on the BYJU'S exam prep app. Okay, if you don't have it, okay, you can get it on the Google Play Store. You can download it now and be more prepared about GATE. And other than that, some short notes, formula notes, many other things will be there on the app. Okay, chalo, next question. For a closed loop system shown in the figure, what is the settling time? Very, very simple question. What is the settling time? Okay, what is the settling time for plus minus 2% settling of the steady state condition? 2% criteria. Okay, the 2% criteria. Tell me. For 2% criteria, tell me. So what it is going to be? So I just need what? I just need, first of all, as always, characteristic equation 1 plus 25 divide by s plus 6 equal to 0. So s square plus 6s plus 25 equal to 0. Don't calculate zeta and omega n separately. Okay, what you can say from here is, this is the value 2 zeta omega n, that is equal to 6. What is zeta omega n? That is equal to 3, and the settling time for 2% criteria is given by 4 by zeta omega n for an underdamped waveform. Okay, and this is going to be 4 divided by 3, and that is 1.33 seconds. 1.33 seconds. Answer is option number B. Answer option number B. Correct. It is a very, very simple option number B. Zeta omega n का value निकालते हुए. अच्छा, just to be confirmed, see omega n is 5. Omega n 5 हो गया. तो 2 zeta omega n is 6. Zeta will be how much? Zeta 0.6 आ जाएगा. It is underdamped. It is underdamped. Why I am telling you this is because I gave you the formula. Okay, like settling time is 4 by zeta omega n. Acha, this is what? This is clearly I mentioned you. This is as per 2% tolerance. This is as per the 2% tolerance. Okay, suppose if it is not the 2% tolerance, okay, if you want to talk about 5% tolerance, if you want to talk about 5% tolerance, settling time will be 3 by zeta omega n. Okay, it is going to be 3 by zeta omega n. ये भी पता होना चाहिए. Now all this is what? Underdamped waveform. If it is overdamped, sorry, critically damped, not overdamped. Suppose if it is critically damped, for zeta equal to 1, we know it is a critically damped waveform. Okay, and the settling time, okay, as per 2% tolerance, settling time as per the 2% tolerance, is given by what? Okay, now in many of the books you will still find the formula 4 by zeta omega n, general formula. No, that is wrong. For critically damped, it is actually given by the formula. Okay, you can call it as 6 by zeta omega n, but zeta to 1 hai, so you can call it as 6 by omega n. Okay, in many of the books you get a general formula for second order settling time. Okay, it is given by 4 by zeta omega n. That is wrong. That is only for underdamped waveform. That is only and only for underdamped. For critically damped, it is 6 by zeta omega n. Yeah, zeta 1 hai to 6 by omega n. Okay, you should be aware about all these cases. Let's go back. Yeah, we were at this question, 1.33 seconds. Next question. Okay. Yeah, guys, before the next question, okay, an important update for you is, okay, just tomorrow at 7:30 p.m. on your favorite BYJU'S exam prep app. Again, I repeat, if you don't have it, download the app from Google Play Store. Okay, I bring to you a free live interactive workshop. Okay, score 13 out of 13. Okay, that is maximum in engineering mathematics. What are the tips and techniques to make yourself score full in engineering mathematics? Okay, engineering mathematics. Okay, you can know it tomorrow 7:30 p.m. on the BYJU'S exam prep app, and yes, engineers can definitely achieve it. Also, guys, if you want to take, okay, you start the journey for your preparation of GATE. Okay, right, want to see where do you stand right now, and if you want to start your journey, okay, looking for some financial assistance, okay, National Scholarship Test can help you achieve it. Yes, you can get up to 90% scholarship on the GATE preparation programs. Okay, appear in this scholarship test this 10 September, that is Sunday, okay, starting from 9 a.m. again on the BYJU'S exam prep app. Next question, the second order system has a closed loop transfer function given to you, 25 upon s square plus 8s plus 25. The settling time for 5% band. For 5% band, as I just told you, it is given by 3 by zeta omega n. And what is this? I have 2 zeta omega n equal to at what is the value of zeta omega n? It is equal to 4. So my answer is 3 by 4. Okay, my answer is 3 by 4. Correct answer is option number B. It is a 3 by 4 seconds. Okay. Which, what ES, Akash, what exactly you are looking for? Acha, steady state error are you asking here? Steady state error? Tell me. So, this is 4 by zeta, this is 3 by 4 is the final answer. Again, you can confirm. See, omega n is 5. Omega n is 5. So, 2 zeta omega n, which is 5, equal to 8. Okay, confirming that zeta is less than 1. So, underdamped formula we can apply. Okay? Underdamped formula is definitely applicable. Next one, a unit step input to a unity feedback system is shown in the figure. Okay, what is the time for peak overshoot? Question is on TP. Again, I am just looking for the characteristic equation quickly. What is the characteristic equation? 1 plus 25 divided by s plus 6, okay, equal to the 0. So I get s square plus 6s plus 25 equal to the 0, and then, okay, I clearly have, what is this? Omega n square. So omega n ka value 5 ho gaya, and then next I have 2 zeta into omega n 5 equal to 6. So zeta is equal to 6 by 10, that is 0.6. Okay, but for the peak time, what is the formula? For the peak time, the formula is pi by omega d. Pi by omega n root 1 minus zeta square. Pi by omega n root 1 minus zeta square. Pi by omega n, what is omega n? That is 5 root over 1 minus 0.6 ka square. Okay, so let's solve it up. It's going to be pi divided by 5. 1 minus 0.6 ka square under root will come up to be 0.8. So it is pi by 4. It is pi by 4. Okay, so approximately 0.78 seconds should be the answer. Pi by 4. Okay, 3.14 divided by 4, up 1.5, approximately 0.78. That is option number C. 0.785. 0.785, so 0.79. Okay, that's okay. That's okay. Okay. No, Akish will be, fixing ourselves to basic transient analysis question only. Steady state error is again an important and different topic. Okay, and already it's 1 hour and there are few more questions of time response only. So we'll cover up time response today. Okay, steady state, if required, I'll take a separate class for that. ठीक है जी, this is done. Very simple question it was. Okay, based on the peak time. Next question coming for you, what it is? A second order system has a transfer function given to you directly. If the system initially rest is subjected to a unit step input at t equal to 0, the second peak in the response will occur at what time? The second peak in the response will occur at second peak. The peak means upar wala na, overshoot. Second overshoot. Okay. First peak and second peak. Peak is above desired value only. Okay, so it is obtained by the formula. See, what is the general formula? Okay, n pi by omega d. N pi by omega d. Agar n ka value 1 rakha, so that is the first peak overshoot. Okay, n ka value next odd number. For odd numbers we get the overshoot, for even numbers we get the undershoot. So it should be 3 pi by omega d. It should be equal to what? This should be equal to the 3 pi by omega d. The second peak in the response will occur at 3 pi by omega d. It will occur at the 3 pi by omega d. Correct hai ji? It will occur at the 3 pi by omega d. Done. Okay, so now that is equal to how much? Omega d nikalna padega. Just have to calculate omega d. Okay, so once again, see, what is this? Omega n square. Omega n is 5 and 2 zeta omega n, that is again 5, is equal to 8. So what is the value of zeta? 8 by 10, that is 0.8. Zeta is known as 0.8. Okay, and then what is omega d eventually? That is omega n 5 root over 1 minus zeta square. Okay, 1 minus 0.8 ka square will be 0.6. So 5 into 0.6 equal to 3. So answer is 3 pi divided by 3. So that is only equal to pi. The final correct answer is just equal to the pi. The final correct answer is just equal to what? It is just equal to the pi, option number D. It is just equal to pi. That is the option number D. Correct? Simple, fundamental. Option number D, that is pi. Next question. Next question. Okay. Now again, look, this is a 2023 question for EC. Okay. But again, as I told you, one more example. This is also a gate PYQ. Okay. So in 2023, especially in electronics, we saw that they have just copied the gate PYQs. They have just copied the gate PYQs. Okay. And in ESE, keep doing it. Not very frequently, but ऐसे करते रहते हैं. Okay, ESE can keep doing it. Okay, doing it, not very. ठीक है जी, done है. Next question. So what it is? Consider a causal second order system with the transfer function given to you 1 upon s square plus 2s plus 1 with the step response rs equal to 1 by s as the input. Let cs be the corresponding output. Okay, CT to reach 94% of the steady state value. Okay. What is the time? I think some statement is missed. Consider a causal second order system with the transfer function gs given to you. Okay, with the unit step rs as the input. Okay. Time taken. ये time निकालना है, ठीक है? Time taken to reach. Okay. What is the time to reach 94% of the steady state value, limit t tending to infinity ct rounded off to 2 decimal places? Okay. Now you are given the final transfer function of the system 1 upon s square plus 2s plus 1. Okay. It is not the forward path gain. It is the complete transfer function of the system. Okay. The transfer function of the system, we know it is the ratio of output to the input Laplace transform, and that is given by 1 upon s square plus 2s plus 1. 1 upon s square plus 2s plus 1, or you can call it as 1 upon s plus 1 whole square. Acha, very important thing here is, okay, what is the value of omega n is 1? This is omega n square, so omega n is also 1. And then 2, zeta omega n is 2. So what is the value of zeta? It is equal to 1. The value of the zeta is equal to 1. The value of the zeta is equal to 1. That means the system is critically damped. The system is critically damped. Okay, what is the step response of critically damped system? Okay, so one more formula I will add on here. It is given directly by the formula 1 minus e power minus omega nt into 1 plus omega nt. Okay, and because it is critically damped, the final value settles to the desired value, that is equal to 1. But you are looking for the time, okay, that the system reaches 94% of the steady state value. 94% of the steady state value. Okay, so what we need? Okay, we need 94%, that is 0.94 of the steady state value, that is 0.94. Okay, this is what we need. We need the time at which this will happen. So 1 minus e power minus omega nt, right, into 1 plus omega nt. Omega n का value कितना है वो लिख लें जरा. Omega n का value 1 है. Okay, so 1 minus e power minus t into 1 plus t is equal to 0.94. So some calculations you have to manage. Calculations you can help yourself. Okay, you have to just manipulate the calculations. Okay, so that e power minus t into 1 plus t will be 1 minus 0.94, that is 0.06. E power minus t into 1 plus t 0.06, and if you just check it up, go with the options. Okay, go with the options, and let me just cross check it once again. Yeah, so it is going to be 4.5. Okay, t is 4.5, and this can be checked by options. Okay, this is a non-linear equation. Don't involve your time in solving it. Okay, you can check it by options. Okay. Yes, Rahul, don't worry. I'll plan very soon a video for first year students as well. What should be the target and strategy for first year students for GATE? Okay, very soon I'll plan that also. Thank you, Prabal. Very good evening. Thank you. Okay, so yeah, this is the next variety of question that was asked, and again they copied it directly from the GATE. Acha, sometimes when they copy directly from GATE, okay, ये अच्छी बात तो है, but they copied it from GATE, but they forgot that in GATE virtual calculators are there, in ESE calculators are not there. Okay, so that is why Okay, that is why yeah, without calculation thoda sa yahan pe tedious hoga. That's what I was just telling Akbar. So they copied this question from the gate. Okay, but they forgot कि gate में calculator है और ESE में नहीं है. So they didn't copy it smartly. That's what I can say, Akbar. They didn't copy it smartly. Okay, next question. The open loop transfer function of a system is given to you 10k upon 1 plus 10s. When the system is converted into closed loop with unity feedback, the time constant of the system is reduced by a factor of 20. What is the value of k? Acha, by the way, what is the time constant here? Okay, what is the time constant here? It is equal to 10 because 1 plus st ka format hai. 1 plus st. Okay, the time constant is equal to 10. Okay, now this is the open loop transfer function. When the system is converted into closed loop with unity feedback. Okay, closed loop with unity feedback. So if I talk about open loop transfer function, let me write down once again. It is 10k upon 1 plus 10s. I get the time constant of 10. Okay, now I want to create a closed loop transfer function. Okay, so that is g upon 1 plus gh. Because unity feedback hai, so 10k upon 1 plus 10s whole divided by 1 plus 10k upon 1 plus 10s. Okay, if I multiply by 1 plus 10s, I get 10k is divided by 1 plus 10s plus 10k. Okay, or I can write this as 10k upon 1 plus 10k constant term ek sath liya plus 10s, but the denominator should be of the form 1 plus st. Okay, so this is going to now become 10k. Sorry, I have to divide by 1 plus 10k throughout. So 10k upon 1 plus 10k upon 1 plus 10 divided by 1 plus 10k into the s. Okay, and now this is your time constant. This is your time constant. Let me call it as new time constant, and that is 10 upon 1 plus 10k. Okay, what we need here, this new time constant, which is 10 upon 1 plus 10k, which is 10 upon 1 plus 10k, correct? 10 upon 1 plus 10k is equal to, it is reduced by a factor of 20. By a factor of 20. That means it should be 1 by 20 of the time constant that you had earlier. Okay, that is 1 by 20 of 10. Okay, upar ka 10 got cancelled. So you are getting 10k is equal to, 1 plus 10k is equal to 20. So k is equal to 19 by 10, 1.9. What is the value of k? It is 1.9. What should be the value of k? It is the 1.9, option number A. What is the value of k? Is 1.9. That is the option number A. That is known as the option number A. Next question, one more on first order. The unit step input to a first order system, this is a good question. The unit step input, okay, to a first order system GS yields a response as shown in the figure. This can happen when the values of k and a are respectively. This can happen when the values of k and a are respectively how much? Okay. Now please pay attention. If I look into this waveform clearly, there is a straight line approximation to this first order response. It's a random sluggish response given to me. Okay, but you know, for the initial it is approximated by a straight line, and this straight line has a slope which is equal to slope of the step response at origin. Now what is going to be the step response? What is going to be the step response? ये कैसे पता करें? You are given GS k upon s plus a. यहाँ से start करेंगे, right? You are given the GS that is equal to k upon s plus a, and I'm talking about step response. I'm talking about the step response. GS, which is equal to CS divided by RS, okay, is k divided by s plus a. Okay, but RS is 1 by s. Let's calculate the step response first of all, because step response ही given है हमको, but in the waveform form. Okay, so what is going to be the CS? Multiply RS on the other side. Step response के लिए input is 1 by s into k by s plus a, and then I would like to break it into partial fraction. Okay, k को separate करते हुए 1 by s minus 1 by s plus a. Okay, this s minus s will get cancelled. A ऊपर बचेगा, तो let me divide by a also, right? So what is the CS I am getting here? It is the k by a 1 by s minus 1 by s plus a. So what is the CT? In the time domain it becomes k by a, right? 1 upon s is the Laplace transform of 1. That is a step. Okay, minus 1 upon s plus a, that is e power minus at. Okay, now slope at origin. Slope is given by derivative. Okay, slope is given by the slope of tangent is given by the derivative. So what is the d by dt of ct? Okay, when you differentiate this, you get k by a. Okay, derivative 1 0 and then minus minus plus a e power minus at. Okay, a will get cancelled. It is k e power minus at. But at origin, what is the slope at origin? At origin t equal to 0. And what is the slope that you will find here at the origin is k e power minus 0, that is k. That is equal to k. Right? That is equal to k. Yes, Akish, we can plan that. Okay. Chalo. So that is equal to k. At the origin, it is equal to what? It is equal to the k. At the origin, it is equal to what? It is equal to the k. Chalo. Done hai. Done hai. Next is what? Okay, now this has a slope. Acha, what is the slope actually? अगर इसका हम slope निकाल लें, by the way, what is the slope of this? Okay, it should have a slope matching with origin. That is okay, but what is the slope? The graphical slope we can calculate, na? The slope is height, that is 5, divided by the base. Okay, that is a time axis, 0.1. So 5 upon 0.1 will be equal to 50. Okay, so that means the slope at origin k, and that should be 50. And I think none of the option is going to match here. They have given something which is inconsistent. Okay, they have given something which is inconsistent in the question, and none of the option will match here. Okay, none of the option will match here. But let me still tell you a kaise nikalenge, how to still calculate the value of a. Okay, now look at the steady state value. The final value of the output is going to be 5.0. The final value of the output is going to be 5.0. Okay, so I have the CT na. Okay, let me continue with the CT. So what is the value of CT? It is given by k by a. Okay, 1 minus e raised to the power minus at. K by a, 1 minus e raised to the power minus at. Okay, now what is the value of limit t tending to infinity CT? Okay, if you put t tending to infinity, it is k by a 1 minus 0, because e power minus infinity is 0, and this is given to you as 5. Okay, this is from the graph. Okay, so that means k by a is equal to 5. So what should be the value of a? It is k divided by 5. It is the k divided by 5. Sir, k aa gaya tha 50. So 50 divided by 5, and that is equal to 10. The value of a should be 10. The value of a should be 10. Okay, so a should be 10. Ye correct hai, right? Okay, so yahan se bhi clear hai na? At least we know that the ratio of k by a is 5, and that also is not matching in any of the option. Okay, that also is not matching in any of the option. Or maybe there is a typo error here in this question. Okay, maybe there is a typo error they have done in this question. We can't say. Okay, but if this is the actual question, none of the option is matching up. None of the option is matching up. None of the option is matching up. ठीक है जी? इस question के according तो option match नहीं कर रहा है. Let me just see if I have the copy of the original paper. 2018 and 2018 EC. Yeah, I think. Let me check whether it is a typo error or they have given wrong options. I'll just confirm it in a minute. Just a second. I'll be there to it soon. Yeah, here it is. Yeah, they have given the wrong options only. Correct. They have given the wrong options only. Definitely none of them will match here. Okay. Definitely none of them is going to match up here. None of them is going to match up here. Okay. Chalo guys. So now if you're looking for, complete GATE preparation, okay, as the full course, okay, with the complete syllabus coverage, you can find it on the BYJU'S exam prep app. Or if you are looking for a crash course, preparing for GATE 2024 and you want the complete study with revision in the last 4 months, you can join the GATE crash course. So both the modules are now available, GATE crash course and the GATE regular full course, and also GATE plus ESE courses are available. Okay, and all of these courses you'll get the live classes, recorded lectures, practice sessions, practice books provided to you, practice quizzes, mock test. Okay, if you want to know more about the details of the course, okay, the fee structure, the timings, and any other query maybe regarding faculty, anything, okay, you can just contact 9241333666. I repeat, 9241333666 and get all your queries rectified. Okay guys, so yes, you will get the PDF of today's session. okay, in my Telegram group. Now I'll just share you the Telegram link once directly in the chat box, so that you can directly join using the links, and then you can have, you know, other discussions like doubt discussions and any other things also rectified in that group. ठीक है जी, I have shared you the link. You can directly join using the link. Okay, chalo guys, that's it from my side. Okay, so bye bye, thank you, good night, stay safe and take care of yourself.